Here is the ink, which contains the solute and the solvent. And what we want to try and do is we want to try and separate the solvent out. We are heating the ink to a temperature of 100 degrees, which will be confirmed by this thermometer here. As you see, it's at the moment roughly around 29, but that's because there is no boiling taking place just yet. However, the vapours are starting to rise. You can see over here the vapours are starting to rise and they're starting to condense on the inside over here. And they're dripping down, but soon this is going to be quite warm. I'm just going to turn down the heat just a little bit. Make sure we have it as controlled as possible. Now, when the vapours come up here, they're going to condense on the inside of this still head, and the bulb of the thermometer is going to have a drip, and the condensed liquid on the cold, relatively cold bulb of the thermometer. Drip is going to come down, and that's a good sign. Let's check the temperature again. It's now starting to rise to 35 and 40. It should rise, in theory, all the way up to 100. The vapour travels after, and so this apparatus is called a condenser, which is like a water slide. On the outside of the condenser, you have cold water flowing in through here, and hot water comes out here. And how did it get warm? The reason why is because the cold water has had energy transferred to it by the vapour that's travelling in the tube on the inside. The vapour then condenses to form a liquid. So you can see on this part you've actually got condensation taking place, and then you've suddenly got a little abrupt wall here, like a barrier. But that's because the vapour has now condensed down to a liquid, and the liquid condensate flows through here, and it can actually be collected into this beaker here.